So let's go on with problem 9.3. Now we want to determine the moment of inertia of shaded area shown with respect to each of the coordinate axes. So let's go through the English first. With respect to 相对于就WRT is 相对于 and then coordinate axis 坐标轴。Sorry, I should put it like coordinates is 坐标 axis is 轴。And remember, and axis is singular and axis is plural. Okay. So let's go for English and then determine what do we need to determine? Determine the moment of inertia with respect to each of the coordinate axes. It means we need to determine Ix and Iy. Okay, we need to determine both. Okay, so and we need to determine Ix and Iy. So we look at the same problem. This one y is equal to kx squared and k is equal to b over a squared. Okay. Now for the definition, Ix is equal to y squared dA and Iy is equal to some integration of x squared dA. And we want to work on this area, small area. For this small area. So it is easier to work on Iy. So we work on Iy first. I use for clarity, I use instead. I think this is it is easier. I will use green for Ix and blue for Iy. Huh? So blue for Iy and green for Ix. Now, and for Iy is equal to x squared dA, so it is easy because dA is equal to what? Equals to y times dx. So, and of course y is equal to this one. So let's do Iy first. Iy is equal to integration of x squared dA, which is equal to definite integral x 0 to a, and then x squared. What's dA? dA is y dx, which is equal to b over a squared x squared dx. And of course, this is equal to y. After this, that the remaining is easy. So for the remainder, this is a to a, and then b over a squared times x power 4 dx is equal to a cube b over 5. This is Iy. Please write it down, and I will talk about it in a minute. So we use the definition. These two are the definition. So we use the definition, and Iy is equal to x squared dA, dx is equal to y dx, and then we simply put y here, and then you know how to do the rest. Now, take your time to write this down. Okay, then we work on Ix. Ix is by definition is equal to y squared dA. So the easiest, if we want to work on this, that we need to have a stripe like this, and then we have y, right? If we want to work on y squared dA, that this is dA, and then we work on y, and we work on each slice, right? By definition, but it is not easy to calculate this one. This is difficult to calculate this one. So we want to use this one as well. So what should we do? We determine the Ix, which is we determine the Ix of this stripe is equal to the Ix. Okay. The second moment of area of this area is equal to the Ix. So we have and then we say we have within this stripe we have dA prime, this little square. For this little square, the area dA prime is equal to dx dy. Okay. So we work on this first, and then we talk about the next step. We work on this first. So the Ix. So how do we determine the Ix? The Ix is equal to y squared times dA prime. Because we are only talking about we are talking about the Ix of this one, and then this one, and then this one, and then this one, and then we only talk about the small squares. Okay. So the lower limit of course, this is equal to let me write it down: y squared dx dy. Oh. Now for this area is dx dy, right? So we do one small area, one small area, and until here. So for definite integral, what do we write here? For definite integral, what should we write here? 0 to what? 0 to the height of this rectangle, which is b over a squared x squared. Okay, I should write it here. I should make it bigger as well. It's okay. Then it is equal to 1/3 of b over a to the x squared to the power 3 dx is equal to b cubed over 3a to the power 6 x to the power 6 dx. We are only talking about the moment of inertia about x-axis for this small area. It's okay. So the height of this rectangle is x is y, which is equal to this is equal to y, right? This is equal to y. So and for each area, which is equal to dx dy. So we do this and this and this and this, and we go on. So for this one, then we get this one. I think you know how to do this. Now we just do some mathematics and you'll get it. Oh, it's good. Right. It's good. Right. Sorry, I forgot to put 2 here. Okay. Now, so we know the moment of inertia of this small stripe. Okay. And let me ask a question. If this stripe moves to here, sorry. If this stripe moves to here and the height is the same, what is the moment of inertia Ix? What's its moment about x-axis? Would it change? Or would it be the same? It will be the same. So this one, Ix here is equal to Ix here is equal to Ix here. So this is also dIx now, if we move to the left. So what we need to do now is, because we know the Ix for this stripe. So what we need to do next is we determine dIx for this one and 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 add them all together. So we add them together. So we have Ix is equal to integration of dIx is equal to, and then we put this one to here. Then we have and then integration is 0 to a. Then it means we have b to the b cubed over 3a to the power 6, and then x to the power 7 over 7, which is equal to ab cubed over 21. Okay, so the green part is for determine Ix, and the blue part is determine Iy.